Hello folks, in this video I'm going to talk about how to use Pi4Micronaut library with a demo using LED. Yay, the LED is working. So first we are going to navigate to Pi4Micronaut documentation. Here we can find how to use Pi4Micronaut library including the screenshots. So for the first step we are going to navigate to Micronaut's website. This is called Micronaut Launch, where you can customize your Micronaut application and download the skeleton of your application. I'm gonna choose Micronaut version 3.10.1, and for the Java version it's gonna be 17, and I'm gonna choose Gradle, and you can choose whichever you like, whichever you're comfortable with, and I'm comfortable with Gradle. And for the name I'm gonna name it demo underscore Pi4Micronaut, and I'm gonna leave this as it is. So finally I'm gonna click generate project and download the zip file. We have downloaded the zip file, and here you can find the commands like how you can navigate to the folder and run your project. So first I'm gonna extract this. I'm gonna copy this onto my desktop, and the next step is I'm gonna open this project using any of the IDE. I prefer IntelliJ, and you can choose Visual Studio Code as well. So let me open IntelliJ. So click open, and I'm gonna navigate to desktop. Here you can see our project which we have extracted. I'm gonna open it. So initial Gradle build was running. Let's wait for a few minutes. Yeah, it's done. So first thing first, let's go to our documentation again. And as I told you earlier, we chose Micronaut version 3.10.1 and Java version 17. We have downloaded the zip file. We have choose our ID and open our project. And then second thing is adding the dependency. So I am using Gradle, and if you want to choose, if you choose Maven thing, then you have to adjust your dependency call. So I'm gonna copy this and I'm gonna add this in my dependencies. Let's navigate to our project, and you can see the build.gradle file. This is the dependencies section, so I'm gonna add the dependencies here. This is Pi4Micronaut utils version 1.1. This is the current version, so I'm gonna say all. It also includes all the dependencies which Pi4Micronaut is using, like Pi4J and other libraries as well. So I'm gonna click build. All the libraries and the dependencies are being indexed. These libraries are available in our project. So now I'm gonna navigate into source, main, Java. Here you can see the basic Java class, and now we are gonna create a controller class here. So let me create a new Java class, and I'm gonna name it as demo LED. And next we are gonna navigate to resources and click on application.yaml file. Here we're gonna define the configuration based on your circuit setup. Let's get back to the documentation. So I have done this step. I have included the dependencies. Now setting up the configuration. So in the YAML file, we're gonna copy and paste this. To explain this, we are gonna use Pi4J library, right, for the GPIO access. So I'm gonna define under Pi4J. It should be under snake YAML structure, and the LED is the digital output kind, and name of the component is LED, and we are defining the address. Initial and shutdown should be low, and the provider is Pi4Micronaut digital output. So we have defined this in our application.yaml file, and let's get back to the documentation. Yes, we have done this. We have created a component class under Java. You can see LED demo, so we have named it demo LED. That's fine. Now we're gonna implement these functionalities in our controller class. So the easiest way is we already defined this stuff in our repository. You can navigate to the components and click on source, main, Java components, and under controllers you can find the LED controller. This is our example implementation. So I'm gonna copy everything and I'll get back to the demo LED class. Let me paste all this here. So this is our demo LED, right? Let me adjust this code according to our project. Now we don't need this. It's not necessary. The controller name and the class name should be same. So all the errors are fixed now. So let me talk about this. So what we have done is we have imported all the necessary statements, and then we are defining it as a controller saying /LED. This is the endpoint where you have to call this endpoint to access the LED. Once you use this, and we're gonna call the methods available for LED by creating an object for it. So this endpoint triggers the LED to turn on, this one to turn off, this one to switch state. Like if the current state of the LED is on, then it toggles to off, and vice versa. And this is to blink the LED for certain duration, and this duration is in milliseconds. So let's build our application. So for building, I'm gonna navigate to the terminal. So this is a command gradle build. So our build was successful. So now under build libs, you can see this, right, with the extension -all. We are gonna copy this onto our Raspberry Pi to run our application and turn on and off the LED. So before that, let me show you how we can set up the LED circuit using our documentation and powering up the Raspberry Pi and other stuff. And make sure in your application.yaml file you have configured the LED with an address 17. So we are gonna use GPIO pin 17 for the circuit setup. So let's back to the documentation, and we have the steps here for how to build and run the jar file on Raspberry Pi and how you can install Raspberry Pi OS. Make sure you have to be on the same Wi-Fi network. I prefer using my mobile hotspot rather than connecting to any home Wi-Fi or university Wi-Fi, because if you have to work on different location, then it might be a problem for you. So always make sure you use your personal hotspot. You can install any of the OS, but I suggest you to install Raspberry Pi OS. And before that, we are gonna set up the circuit for LED. So let me navigate to LED. We have everything here, like what components you need. We're gonna need a Raspberry Pi, a breadboard, a T extension board, an LED, two jumper wires, and a resistor with 220 ohms. Of course, a power source. And we have the assembly instructions as well, like how you can set up your circuit. And this is the circuit diagram we need. So by using this circuit diagram, we are going to make the circuit right now. Let me get my hands onto the Raspberry Pi. So this is our Raspberry Pi. Currently I'm using Raspberry Pi version 4B, and it uses Type-C kind to power up. And these are the GPIO pins. It has 40 GPIO pins. It's hard to identify each of it, right? So we are gonna use a T extension to access it very with ease. You can see the numbers and the name of the pins. So we're gonna extend it. And this is a breadboard where you can add all the components you need. And using my circuit diagram, I'm gonna set up an LED circuit. This is an LED. And this is a 220 ohms resistor. I added that, and now I'm gonna use GPIO 17, and we have to make sure our ground connection is established. So I have used GPIO 17 and the ground connection. So let's power up the Raspberry Pi. I can use any of the travel adapters or the mobile adapter, and this is a Type-C cable. And for now I am gonna use my power bank to power up the Raspberry Pi. As you can see, the lights are blinking. That indicates our circuit, the Raspberry Pi is booting up. And we need a memory card to install our Raspberry Pi OS on the Raspberry Pi. So I suggest to use minimum of 8 GB, and this is a 32 GB card, and I already installed Raspberry Pi OS on it. And one more time, make sure you connect to the same Wi-Fi network. Let me install the memory card and boot it up again. So I'm getting back onto the Intel IJ. I have to make sure my Wi-Fi network is common for both. This is my mobile hotspot. Let me connect to this. So once the connection is successful, now I'm going to copy this jar file, which is located under build libs, and make sure you copy the one with -all extension, which has all the dependencies necessary to run the jar file on Raspberry Pi. So now I'm gonna copy the path reference, absolute path. I'm gonna open a new command prompt window. The command to copy is scp, paste the path of the jar file. This is the jar file which we have built, and now we have to provide the destination, and our destination is Raspberry Pi. So I'm gonna give Raspberry Pi name, API dot local. You can use a Raspberry Pi IP address as well, and we have to mention the path colon slash home slash Rutwik. So this is a path, and now I'm going to click enter. Now I'm going to enter my password. As we can see the progress, it's 100% and the jar file was copied successfully. Now let's SSH onto the Raspberry Pi. The command is SSH and our Raspberry Pi name pi.local. Let's try again. It's asking for the password, so I'm going to enter my password. We are in the Raspberry Pi terminal. Let's see the jar file. So this is a jar file which we have copied. So now let's run this jar file. So to run the jar file, the command is sudo java -jar or demo underscore pi4Micronaut.jar file. I'm going to click enter, and you can see the Micronaut local server is running on Raspberry Pi, and you can access that server using this HTTP link. So let's copy that, and now I'm going to open another command prompt window and again SSH onto Raspberry Pi using the Raspberry Pi name. Let's try again. Now it's asking for the password. So let's use curl commands to interact with the LED, and the command is curl, and we're going to paste a link which we have copied, and as I told earlier, we need the endpoints. Let's check out the code and make sure we are using the correct endpoints. And here you can see, for to access the LED we have to use this slash LED. So I'm gonna type slash LED over here and slash, and if you want to turn on the LED we're gonna say LED on, and here LED on. Make sure you don't have any typos. And now let's see whether the LED turns on or not. Let me turn off the main light so that you can be able to see the LED turning on. And now I'm gonna turn off the LED, and for the command is LED off. Here you can see the command for turning off the LED. So I'm gonna use this endpoint to turn off. Let's click enter, and it's turned off. So now we can use switch state function. So currently the LED is turned off and it turned on. So I'm gonna use the switch state again, and it's gonna turn off. Now we are left with one more function that's called blink function. So blink, and I'm gonna say 20 microseconds. So it's gonna blink for 20 seconds. So let me show that again. So that's how you can use Pi4Micronaut library to interact with the electronic component. This is just an example with an LED, and you can use our 16 components which we provide support for. That's it for this video. Thank you.